Hello everyone. So today we're going to be working with some more advanced types of problems. So we would like to start with one that is kind of long to read, but I think once we get the gist of it, it's fairly simple. So it says, my company produces 6-inch tall cans of paint. So cans of paint, we should start thinking about cylinders. These cans have a radius of 15 inches. We want to offer a supersized can of paint. Toby wants to leave the can just as wide as it is, but increase the height by X inches. Mariana thinks the fat can sells better, so she wants to make them even wider. So she wants to increase the radius by X inches. After they argue for a while, they decide to use the design that produces the greatest increase in paint volume. They reach for the scratch paper and figure out how much more paint is needed to fill the new can designs. They both use the same value of X, and they both find that their designs require the same increase in paint volume. What value of X did they use? Okay, so even it's very wordy, but let's take the key pieces of information. We have a can, which implies cylinder. We know that the default size is 6 inches for the height and a radius of 15. And we know that one can is going to increase the radius by X inches and another the height by X inches. And we know that both designs require the same increase in paint volume. So what that is implying is that the volume, so like volume of Toby is equal to the volume of Mariana's. Now, what can we do with that? Well, we know that the volume of a cylinder is equal to pi r squared times the height. So, let's think about Toby's can. Toby wants to increase the height by X inches. So, let's write an expression for Toby's volume. Okay, so we have pi. Now, in Toby's can, it's just as wide as it is, which means that the radius is going to stay the same, and we know that the radius is 15. So we're going to plug in 15 squared, but the height is going to increase by X inches. So we're going to take the regular height of 6 inches and add a value of X to that. Now we have the volume of Mariana's. I'm just going to put Mary, which is pi. Now, Mariana wants the radius, she wants the radius to go even wider. So she is going to leave the height the same. But when we calculate the radius, we're going to take the default radius of 15 and add a value of X to that. But we're going to keep the height exactly the same. And we know at the end of the day, these two formula are equal, so let's set them equal to each other. So we have pi 15 squared times 6 plus X is equal to pi 15 plus X squared times 6. Okay, well, immediately we should see that the pi on each side is going to cancel out. So we can just kind of cross those out of our problem. So 15 squared would get us 225. And we're going to multiply that in a minute by 6 plus x equals... Now, we would have to expand this binomial out. It's a binomial squared, so make sure you expand it correctly. You do 15 squared, 225, plus 15 times x times 2 is 30x, plus x squared, and we're going to multiply that by 6. Okay, so moving forward, we have 225 times 6, which I'm just going to write as that 225 times 6. And what I'm going to do is distribute this 225. And you're going to see why I'm going to leave it like this in a second. So then we have plus 225x equals, now distributing this 6, we have 225 times 6 plus, we have 6 times 30, which would be 180x. And then 6 times x squared, which is just 6x squared. Now, hopefully you can see why I just left the 225 times 6, because since we have it on both sides of the equation, we can just cancel those out. Now, what can we do from here? Well, let's subtract 180x on both sides. I'm going to write our work over here now. So we have 225 minus 180, which is 125 minus 80, which would be 105 minus 60, which would be 45. So we have 45x equals 6x squared. Now let's divide both sides by 6x to get, well, importantly, so that the x's here will cancel out, the x's here cancel out. Now we have 45 divided by 6. Well, 45 is 9 times 5, and 9 over 6 would reduce to 2/3. So 3 times 5 is 15. We still have the 2 in the denominator, equals x, which means that x is going to be 7.5 inches. And that's our answer. So, as you can see, the math is a little tough. It requires a lot of algebra, especially like quadratic skills. But the important part is knowing what information to take from the word problem. It's a very lengthy word problem, but we're only going to use what it's telling us to use. It's obviously a volume problem since it says their volumes are the same. We know what the formula for volume is. It gives us a value for height, and it gives us a value for radius, so we know what to compare it to. Once you set up the equations evenly, from there it's just algebra. So just make sure in any of these word problems, use the information it gives you, set up some equations, and hopefully you can see where to go from there.